Hello, this is Mr. Jared, and in this video I am going to be taking you through the What is Engineering presentation. So part one of this presentation, in class we would be doing a quick little breakout. So I normally say you and a partner go through these few questions here, kind of discuss it. I try not to have you really look it up online. I want you to have your own opinion and give your own description of this. So what is engineering? What is the role of an engineer in our society, even maybe our local community, because we do have engineers around here. Why do we change products, and who does it affect? What is the term for creating a brand new product, and provide an example? And what is the term for improving a product that's already existing? Okay, and give an example. So if you want to pause the video for a little bit and kind of just think those questions through, we will kind of answer a lot of this as we go through. So common mix-ups. So I basically say here that an inventor is somebody who creates a brand new product, okay? And an innovator is somebody who is a creator of an idea or product that stems from an already existing idea or product. So that might be confusing to read that, but basically an inventor creates something brand new. An innovator improves an already existing product. So that's also the answer to number 4 and number 5. Maybe some examples here. The very first ever cell phone, okay, would be a brand new product. Now you could also say, well, isn't that kind of just an improvement of the very first phone? So wouldn't it be an innovation? I guess it's kind of an innovation, but really that is a brand new product because it was a cellular device and they didn't have that before. Okay. Then I kind of give them two different definitions here. And these are my own personal definitions. I might be slightly wrong on this, but this is kind of what we're going to talk about during class and what we're going to go with. So my own definition of an engineer is a person who is trained in and uses technology and the scientific knowledge to solve problems. Normally, they do not focus on aesthetics, so that's how something looks, but instead they focus on its function. Now, I'm sure they probably do focus on this, but I would think an engineer's main concern would be its function. Okay. A designer, on the other hand, is a person who plans the form before it's made. So they're probably focused more on the aesthetics, how it looks. Okay, so you got form and function. And you'll hear there's a marriage between the two or a battle between the two of how something looks and how something works. Okay. So then this one says the product life cycle. So the constant circle of redesign that products go through. So in our discussion of answering some of these questions, what is an engineer? That's kind of was answered on the next slide, and it says what's the role of an engineer and why do we change products and who does it affect? Well, this slide kind of comes into that same conversation. We change products and we adapt products, maybe to improve a new problem, or maybe because we have new technology that we can incorporate to make it better, or maybe it's simply because we want to financially make more money. One car drives you to point A and point B. They might change the color. It really didn't change the type of the car or what its actual function is, but now it appeals to a new market, so a new group of people because it's a color that they might like. So maybe sometimes we also change things for marketing abilities. But every single time you change stuff, if you categorize all the people that it affects into smaller groups, you're going to affect the manufacturer, the customer, and the designer. Okay, now, yeah, there's a lot more here. You could even say, what about the sales rep, the store that has to sell it itself? They have to now figure out the shipping of it. They have to figure out new space on a shelf if it goes on a shelf or a floor space. The consumer, like when they're using it, who's buying it, maybe how it's going to be recycled. Even the designer itself, so of designing it. Well, then this just says the people that make it. Well, what about the people that make the tools and the machines to make the product itself? So there's a lot of actual categories and other people that a product really affects when it changes. Okay. But I just posed these two questions. We didn't really answer them. It says, where did the idea start off and what's to come? So I kind of give you this little comical picture down here at the bottom. You can see the Flintstones, the old bedrock days, caveman days, and then the Jetsons cartoon of flying around in their hovering vehicles. So I kind of also gave you a small timeline of just the change and the innovation of the average day mobile or car. So what it used to be and what it is now and what it's continuing to be. And I know now is way past this picture, but it's just showing you the product life cycle. Things are constantly getting redesigned and improved. And then I also explained to students that I used to do a project, sorry, with students where they had to research some type of product and how it came about and how it's improved over time. And this was just an example that one of my students handed in, and I always found this interesting. They did the first toothbrush, and they found out that the first toothbrush actually dates back to 5,000 years ago. It's probably more than that now, but the Babylonians rubbed a chew stick, as they called it, on their teeth and the mouth to clean their teeth. So then in 1498, a bristle brush or toothbrush was created in China. Okay, the bristles were actually stiff, coarse hairs taken from the back of a hog's neck. Remember, a hog is basically a pig, okay, a pig that rolls around in the mud, the dirt, everything else. And it was attached to handles made of bone or bamboo. So I kind of found that interesting. And where did that go from? So the first toothbrush, Egypt or the Babylonians, and then it shows the bamboo toothbrush with China, okay, with a boar's hair, and then how it adapted over time. So this one says cow or horse hair on bone. Then in like the 30s, it says that nylon bristles. So somewhere in between this time and this time, somebody had to invent nylon itself. Then somebody also probably put it into the toothbrush. They found a use for it. It also looks like in this picture, you can see this one up here is on bone, and it almost looks like this is on plastic. So plastic also had to be manufactured somewhere in between this time. So they took different ideas and they improved upon this idea to create a better innovation of the common day toothbrush. The next evolution of the toothbrush came to the actual electric toothbrush. So I really find this amazing. You see, this is in 1954. It said in Switzerland they had a toothbrush that plugs into the wall. So this was probably a corded toothbrush. It needed to be plugged in to actually be used. So it wasn't like a wireless charger or anything like that. But I find that amazing. I didn't know that in 1954 we had an electric toothbrush. There's a lot of people that don't even use electric toothbrush now. Okay, then in the 60s it says the automatic toothbrush had a charging dock. So I'm guessing it went from a wired toothbrush to a wireless toothbrush. In 2007, they changed the head up so it's not just vibrating probably. Here now the head actually moves, it oscillates, moves back and forth, as you can see these arrows. 2014, they came out with a smart toothbrush. I find this a little funny. I guess it hooked to an app. That's probably why they're showing this here. And I believe, from what the student told us, is that it actually records how long you're brushing your teeth for and the different locations of your mouth that you're brushing your teeth in. How long you're actually doing it in like this quadrant versus that quadrant of your mouth. And that was only in 2014. They have definitely improved it since then. So you can see we had an invention and then all of its innovations over time. Okay. Then we actually talked about the evolution of a watermelon. This is just a naturally made fruit. It's planted, it's grown. How did humans actually change this or evolve this? Well, you can see in this picture up here at the top, you have your typical watermelon. It's round, or sometimes it's more like an oval shape. And then these pictures down here, it shows that they're manufacturing them, or they're manufacturing a box and allowing this to grow inside the box, which then creates more of a cubical, not a spherical, a cubical watermelon. So I show them, show the students a little video here. I'm not going to actually play this video, but I would highly recommend you going into the actual presentation itself and watching the video because you can see why they do it and how they do it and how expensive it is, and that kind of sparks some conversation in the in-person class. Then I kind of give them my innovation. I just give them an example of, when I had to do something like this. So I had a class in college where we kind of went over this similar topic, and the teacher basically said, all right, you have the rest of class today, and I'll see you in 2 days, and I want you to come up with a simple innovation of a very simple product, of something that you can improve upon it. So, that didn't really give us too much time. I knew I was busy over the next course of the 2 days. So I kind of just wanted to get a jump start and pick something simple in the room. So that teacher always knocked his whiteboard marker or his expo marker off of his tray, and it always was falling on the floor. Same thing with his dry erase. I really don't understand why he couldn't just lay it on there. It just always fell off. And we always used to laugh about that as teachers. So I said, hey, how can I improve that simple idea? So I came up with this idea, and I kind of just took a marker apart and I 3D modeled the entire thing, and this is what I came up with. So I made an expo marker, basically looks the exact same, except on one side of it, I would have a little raised up piece of plastic, and towards the bottom, I'd have another smaller circular raised up piece of plastic. So my idea was this is going to be a magnet. You could just have a magnet that's already glued in there. And when they sell the marker would come in one single marker with maybe an adhesive strip of felt. Okay, so this is a felt piece with an adhesive back. So when you open the package, you peel off the adhesive and it sticks onto this piece. And you can see that it's raised up, but it's even with the actual magnet itself. So what this would allow you to do is draw on the board, turn it, you could erase, and you could even let go of the marker, and it's already magnetic, so it sticks to the board itself. So this was an idea I had in college. A few years later, I'm at the store one day, and I realized they're now selling markers with a very similar idea. And I find that very funny. I wish I would have actually done something with that idea. Maybe somebody else already had that idea beforehand. I don't know, but I can tell you I never saw the markers before I actually designed this. So the markers they commonly sell now, the magnet is on the cap itself. Mine was actually built right in here. I actually tried to 3D print this back when I was in college, and I can tell you that's when our 3D printers were not the greatest. They have definitely come a long way. So you can see in this picture, I have my marker itself 3D printed. I took a piece of felt, basically just took an old dry erase marker and cut off some, or not the marker, the eraser itself. And I just cut off some and glued it in this little piece, the rectangle piece that's raised. I glued in a little magnet that I bought at Michael's, and you can see this example over here of me holding it, and it almost gave me a finger grip, so I really liked it. And with that finger grip, you can kind of just flip it around, and that eraser part is already on the board itself. So, not saying that I'm a genius or anything. This was just a simple innovation of a very simple product that was laying around. So we go through a couple more videos in class. Again, I'm not going to play these during the screencast, but I would highly recommend watching them because they are interesting. Since we do woodworking here, I posed this video and I showed this video. This is taking the idea of a table saw and actually incorporating technology into it as far as a computer goes to add a lot of safety to it. So I would watch this video as well. Then I kind of showed the innovation of a simple bowl, how they use a gimbal in there, and the little gyro effect itself, so the bowl does not spill. Okay, so this is just a very simple kid's toy, but again, it's very interesting. Sparks a little bit of a conversation in class, and it's interesting of how they use that technology in other places. Then I show this video of it's an old TED Talk video of an innovator or an engineer. His name is Johnny Lee, and he actually shows you how he hacked into a Wii remote and changes it into a smartboard. Now, smartboards have really gone down in price. This video that he did was, or this TED Talk video he did, was much older, and it's when smart boards were very expensive. They're not very cheap now. That's not what I'm trying to say, but he actually took an already existing piece of technology in a Wii remote, and he figured out how to reprogram it so that you can do it at home if you want. So again, another interesting video. And if you go on to his website, I believe if you just Google search Johnny Lee, you'll probably find this gentleman, and he has a website that I know he actually uploaded this code and the steps of how to actually do this yourself at home. Then I showed the students the innovation of a tire. I told them that when I was in college, I had a class called Futurology. So it was a technology class, but the study of futuristic technology. So one of the assignments in the class was we had to research technology or some type of product that was in beta form and try to find out whatever information we could on it and then present it. And one of the presentations I did was on the airless tire. So this was something that I heard about from a friend who is in the military. And I believe Michelin initially was working with the military singly, and they were trying to come up with a tire that had no air in it so that their soldiers overseas or wherever they were at, they weren't as vulnerable because their tires of their vehicles could not be shot out, okay, or popped in any way. So this is pretty interesting because I believe now they're actually just starting to come out. And when I did this research project in college, this was a long time ago. So it's interesting that now they're actually coming out for civilian use. So again, another interesting video that I would recommend watching. And then part two, this is probably the second day that we do this presentation because there is a lot of discussion and a lot of video watching. Part two, we kind of just do another breakout session. So it's the engineering fields. And I tell the students that, all of these fields are not all of the ones there are. These are just some of the main ones that some of the students found, or the initial ones that we spoke about when I very first did this presentation. So stage one is doing some initial research. So it says 5 minutes to research and develop your own description of the following, okay? What the engineering field is/does, okay, and why are they important to our society? So it says record your answers somewhere so you don't lose them. Well, I will explain that part of it then. But then we go down through and I just show them some basic fields here, and I kind of say there's four main branches of engineering, and I put them in red. And then there's all these subcategories. So like architectural engineering is normally a subcategory of civil engineering, and we discuss why that is. Okay, so you can also look that stuff up. But we go down through and I just named a couple: group one, group two, or student one, student two, depending on how many students we have in class. Automotive, mechanical, electrical, electronics, computer and software, agricultural, environmental, chemical, and then biomedical, medical, clinical, manufacturing and industrial engineering, aerospace engineering with the subcategories of aeronautical and astronautical. And then, of course, there's some extras here too. Then there's probably a lot more that I'm not mentioning. But these were just some that we wrote down as a class. Normally, this class consists of 14 or less kids, so that's why I only kind of capped it at this. So there's materials, and then I put some other ones here as well. Every once in a while, I have some students that are interested in these, but mainly the previous ones are covered by the students in the class. So I have them researching those questions, and I'm going to jump out of this really quick and go back to our assignment list. Now, when you're watching this video, this assignment list may have changed. I change this all the time, but somewhere near this presentation, I also have a presentation note sheet. So normally this note sheet is very similar to the presentation itself. It just has kind of some simple columns with all of those engineering fields that you just saw in the presentation. A spot for the students to put their names. I kind of took their names out of this. And you can see that we did this last semester, and I did not reset this yet. But you can see that they put their answers 1 and 2 to those questions that I posed in the presentation. Now, when you're watching this, these questions might have changed or something else might have changed, but basically this is shared to everybody in the class so that you can edit it and put your answers in here. And then we just go down through and we discuss it. The students read off what they researched or what they found, and then I kind of maybe chime in with some more, or I chime in with some real life stories of things that I've heard over time or whatnot. Okay, so going back to this, at the very end of all the students presenting their findings, I pose this question again: what do all of these different types of engineers have in common? And that normally sparks some type of small conversation, but that all circles back to where we first started, and it's what the role of an engineer actually is. Okay, so engineers set out to solve problems with the idea of making concepts more efficient and making life better. So, of course, they're using STEM features, so science, technology, engineering, math. They're using all of those different ideas to improve our life, but really, we're trying to make it more efficient, and we're trying to make life easier, better, or more marketable for certain products. But engineers, in the long and short of it, solve problems and they improve aspects of life.